Okay, so let's continue on our lessons from last week, a little bit from last week, because uh, we actually have finished all the topics for the force, but I want to resume to give some uh, examples, okay, regarding our topics. Okay, so let me share the slide. Okay, so I believe we have discussed all the topics. Okay, we have covered everything, but I want to emphasize on the usage of or the applications of the force. Okay, applications of the force uh, is obviously, okay, might be using or can also uh, be discussed in terms of how the force can affect the kinetic friction. Okay, so the words friction means, okay, it opposes all the motion. So if the motion goes to the right, that means the friction can go to the left. Or should I say the directions of the friction should always oppose all the motions. So regardless of where is the motions can be. Okay, so when you look to the friction itself, the friction is can be divided into a kinetic friction and also a static friction. Okay, so for kinetic friction, we use a equation Fk equals to mu k times, and N stands for normal, okay, normal force, and mu k is the coefficient. Okay, this one is the coefficients of kinetic friction. That means the coefficients is given by a certain value. Okay, then uh, uh, you cannot memorize all the values, but maybe inside the question, the coefficients of kinetic friction can be stated in the question, or maybe it can be asked for you to derive it, okay, or to find it in the questions, right? So calculating the kinetic friction force is easy, okay, but again, okay, I should remind you to the words of kinetic friction. Okay, and of course, in the kinetic friction involve normal force. And when we talk about normal force, okay, the normal force or N always be related to summation of Fy. That means um, the force that is in the vertical components. Okay, normally in the vertical component. But for the friction, normally we happen to discuss or to the friction should happen in x-axis. That means when the question involve kinetic friction, or when the question involve any friction, you should know that you need to establish both summation of Fy, okay, equals to MA or equals to 0, and maybe another one is the summation of Fx equals to MA. Okay, maybe MA or maybe equals to MA, or maybe equals to 0, depending on the situation whether the acceleration is there or not. Okay, so these are the coefficient of friction as I said in the class last week. Okay, the mu s and also the mu k. As you can see, the mu s or the static friction, okay, obtain a higher value compared to mu k. As you can see, these are the table that involve the coefficient of friction. That means you can see from both perspective of coefficient of static and also kinetic, that happens to be between the surface of, or the contact surface between the object and also the surface. Okay, that means the coefficient is where you can see uh, from the surface of of anything, maybe the floor, maybe in terms of rubber, steel, and between the body. Okay, so these are the tables of coefficients of friction. Okay, so by using a certain numerous attempts, such as Newton's third law, this one, okay, if you are given like this, okay, if you are given um, um, object that happens to be put in, okay, on the floor, okay, that means the object means have an mg, okay, that means the weight, okay, of course it will contain the normal force, okay, and at the same time, if there is some external force, that means it goes to this way, okay, and will have some theta, so you need to uh, describe it, or you need to put that theta in terms of its component. That means this one is FAPP cos theta, and also FAPP sine theta for the vertical component. Okay, that if the motion is going to the left or you going to the right, okay, your right, okay, maybe this box or the object is going to the right, and of course the friction should oppose the motion, must let's go to the left side. So when you write down the equations, you need to consider these things. Okay, so as I mentioned to you, okay, these are the equations that involve, and how to get the equation is started from the submission of Fy equals to 0. Okay, why Fy equals to 0? Because in this kind of situation, okay, the box is not moving in y direction. The box is not moving in y direction. Therefore, we should appoint. So there is a normal force. Where is the normal force? And minus with Fy, you have here mg, and a minus is F applied for vertical part. So FAPP sine theta is also equals to 0. And when we bring to that side, to the other side, then it will become this equation. So you should not memorize the equation, but you need to derive the equation based on the situation, because okay, the situation is not all question involve applied force. Okay, so that means you need to look carefully whether there is a applied force or another external force involved in the questions or not. Because if there is no applied force or external force, that means you don't have to put this value. Okay, so in fact, you need to just involve N and mg. Okay, so as you can see, okay, all the forces that involved here, okay, is derived from the figures that contains a free body diagram. So again, this is a free body diagram. That means all the forces should show or should point outward from the center of mass. Okay, so this is called center of body, center of mass. That means we started with at the center of the pusat kepada object tersebut, and of course the free body diagram, all the forces should point to the outward position. Okay, that means all the force should be out. Okay, as you can see, or as we have go through the tutorial, okay, the question involve some forces. Okay, that means you can see one question involve a force that have been pushed, okay, at this side. That means the arrow is going into the box. So you cannot have this as a free body diagram. You need to extend this, okay, extend the arrows so that the arrow should point outward from the center of mass. Okay, so that's how we done. This is in terms of Fy, okay, but this one is in terms of Fx. So in the Fx position, you can see the applied force should contain what? F applied cos theta minus with Fk, or minus with the kinetic friction. The kinetic friction comes with the equation of mu k times n. And remember, n is mg minus F applied sine theta. Then you can solve the problem that involve maybe some acceleration, or maybe they want you to find the coefficients of kinetic frictions. Okay, so this one is in terms of static friction. Okay, the static friction, not always. Okay, the use or the difference between static and kinetic friction is where you can see in the static friction. Okay, normally that is the first friction that involve in motion. Okay, because when object is started to move or starting to move, okay, so it's always start with the initial. That means it start from rest. At that particular rest, the rest position or the rest situation of the object, that means there is a static friction involved. Okay, so that's why the static friction it should be thought earlier compared to kinetic friction. Okay, the mu s and mu k, because the equation that involves static friction is always mu s times with normal force. The same equation as Fk, but this one involves mu s. Okay, if that is where the situation where the object is started to move, okay, due to the static friction, as I have demos in the class. Okay, look, okay, and therefore you can see here, okay, a graph of the magnitude of the friction force versus an applied force. So you can see here when there is a friction, okay, and then it goes to this point where the static friction is maximum, and then afterwards we can continue with the kinetic friction. And then in the kinetic friction, okay, the friction have been um, okay, in the constant value. Okay, but before it reached to the point where it started to the object is started to move, so it should contain a static friction. Okay, the static friction will build up from zero until a maximum of static friction, and after the static friction reaches maximum point, the friction after that, we can call that as a kinetic friction, and the value of the kinetic friction should stabilize and become constant throughout time. Okay? So the magnitude of static friction acting on an object at rest satisfy the inequality shown where n is a normal force and mu s is the coefficient of the maximum static friction between the object and the surface. The force acts in the direction opposite that of the impeding motions. Okay, so that is how you maintain the mu s. Okay, let's look at the examples here. Okay, suppose a block with a mass 2.5 kilogram is resting. Okay, the word resting, that means okay, the box is not moving on a ramp. If the coefficient of static friction between the block and ramp is 0.35. Okay, look at the word coefficient of static friction. So this is the mu s. Okay, between the block and the ramp is 0.35. What maximum angle can the ramp make if with the horizontal before the block starts to slip down? So you can see here, this is the ramp at that contains certain angle. So if we want to make sure, or we want to make a box that is starting from rest, okay, at first it become at rest, so started to move. So what is the maximum angle can be? Okay, now, okay, all we must make sure that we should understand the incline situation. The incline situation like this one, okay, contain mg, okay, as I mentioned, contain mg, and of course, the probability of the box is going, okay, or the acceleration of the box should be in that position. That means the acceleration, if the box wanted to slip down, so it should goes to the incline, okay, down the incline, where the frictional force should oppose the motion at this way. So that's why they are setting the arrow of the friction force or static friction that oppose the motions of acceleration. So as usual, we need to find the mg sine theta and mg cos theta. You don't have to put the negative here, as stated. Just make sure you understand the mg cos theta should be minus because it's pointing downwards. Okay, so there you can see there's the mg sine theta, mg cos theta, and also, of course, the normal force. So at first, you need to establish some equation at fx, okay, summation of fx equals to ma, but the box is not moving, therefore this one become 0, okay, as stated in this part. Okay, okay, so mg sine theta minus with mus. Mus is this where is the static friction times with the normal, and regardless of the normal. Okay, now use fy equals to 0. Okay, why? Because the box is not floating around. So n minus with mg cos theta equals to 0, n equals to mg cos theta. Then you can put this n into this part. Okay, and then you may find that there is a mg sine theta minus the mu s mg cos theta. But this one, okay, how can they get tangent theta? Because that is due to sine theta divided with cos theta. So as okay, I will show here mg sine theta. You bring this part to the other side. They becoming mu s. Okay, so that means, okay, we bring the mg cos theta to the side, mg cos theta. So m and g you can cancel out. There goes sine theta over cos theta. So you can have tangent theta equals to mu s. And then you can find that, okay, so the mu s is 0.35, the theta is equivalent to 19.3 degree. Okay, now let's go to the side of how to apply the kinetic friction. Okay, the hockey puck, okay, in figure struck by a hockey stick is given an initial speed of 20 meters per second. So this one is a v naught. Okay, on the frozen pond, the puck remains on the ice and slides 120 meters. So there is delta x equals to 120 meters. It's slowing down steadily until it comes to rest. That means v becoming 0. It determine the coefficients of kinetic friction between the puck and the ice. So they want you to find the coefficient of kinetic friction. That means the mu. Okay, remember Fk is equivalent to mu k times n. So you need to find what is n. And of course, you want to find what is Fk. Okay, so you need to establish some ideas regarding this one. Of course, when you are given the delta x, v and v naught, okay, you may find it as a acceleration. Okay, because the puck is slowing down, so we might get that value will be negative because this is deceleration. Okay, deceleration and slowing down until it come to rest. Okay, and then you put that the summation of Fy equals to 0 again, because the puck is not floating into the air. It is just maintained on the x-axis alone. So the Fy should be equals to 0. Therefore, n minus mg, because according to this situation, okay, we may have some normal force and also mg. And because the motion is going to the right with the some acceleration, then there it goes. The friction force should be opposing the motion. Okay, so n minus mg equals to 0, n equals to mg. So we can have n equals to mg. And then what happened to the fk, right? So you need to use a summation of fx equals to ma. Okay, fx equals to ma, but there is no there is a f inside the x-axis, which is the just fk. So in, this one doesn't have any force on the positive x. Therefore, so it becomes negative fk equivalent to ma. Okay, negative fk equals to ma. So you may see, right? Because why? Because 0 minus Fk equals to Ma, so negative Fk equals to Ma. Okay, and of course, because acceleration is negative, so we can cancel out the negative and negative of the acceleration in order to find the mu k is equivalent to 0.17. Okay, you can try it out. Let me show you other, not this one. Okay, maybe this. Okay, okay, with I think this one. All right. Okay, a block with mass M1 that is equivalent to 4 kilogram and a ball with a mass M2 equivalent to 7 kilogram are connected by light string that passes over a frictionless pulley as shown. Okay, so this is a frictionless pulley, right? So the coefficient of kinetic friction between the block and the surface is 0.3. So where is the kinetic friction should be? Because the acceleration is going that way, so the mu k should be here. Yeah? The kinetic friction should be opposing the motion. Okay. How about the ball? Or how about the a ball M2? Okay. Ball M2 is hanging by a thread hanging by the string, a light string. So it shouldn't have any friction, okay, on M2, because friction only involved when there is a contact between two surfaces, right? So especially for the friction, kinetic and static friction. Okay, but in this case, we have assumed that all the air friction, it doesn't involve here. So that means when you look at the free body diagram involved in M1, so you may see there is a normal force and M1G here, M1G. Okay, we should put a subscript of M1. Okay, and M2, of course, there is a M2G. Okay, and because this M1 and M2 have been connected using a light string, that is the same light string, that means the tension should be towards each other. Okay, towards each other, and it should be pointing to the pulley. Okay, pointing to the pulley. There we can have some certain or some situation like this. Okay, so this is for M1, the free body diagram for the M1. Okay, the free body diagram is very important. Please do it as your practice. Okay, if you want to solve the problem involving force, okay, make sure you do some sketching about free body diagram. Okay, in fact, in your midterm test, when there's when there's a question about application of force, make sure, okay, look at the questions thoroughly, because I think, okay, most probably all the questions should have or should contain how to sketch or please sketch the free body diagram for the questions. Okay, of course, okay, 90% I'm sure there is a question about sketching free body diagram. Okay, now you may see the system of M1G and M2G. Okay, as mentioned here. Now we can use to find the what you call that? Find the accelerations of the two objects and the tensions in the string. Okay, of course, when the question of the pulley, okay, and involve a light string, okay, connected in light string, there is most probability the question will ask about tension and also acceleration. Okay, of course, when there is a tension, then you can obtain some acceleration. Okay, so like this one, okay, these are how they did for the first time. Okay, so when you look at the first part, okay, that means they establish first what is the summation of fx, because summation of fx should be equals to m1a. Okay, because when it involves, you can see here, these are the acceleration at m1, and the acceleration that is go to m2 is going downwards position. Okay, but uh, fortunately, okay, that acceleration is the same, but in terms of direction, of course, the directions of acceleration at m1 should pointing to the right or to the positive x, but the acceleration for the m2 is pointing downwards. But regardless of that, the value should be the same. Okay, so m1a. So why m1a? Because that is only involve m1. Okay, and how about fx? So fx, we have t and we have fk. So t minus fk equals to m1a, and then there is the summation of fx. How about the summation of fy? So fy equals to 0 and minus mg equals to 0 and equals to m1g. Okay, we break for 1 or 2 minutes. Azan. Okay, boleh dengar suara saya ke?
Boleh je.
Boleh je.
Okay. Okay. Okay, boleh nampak slide tadi?
Boleh je.
Alright. Okay. So again. So okay, the n for summation of Fy equals to 0 and n minus mg equals to 0. So n equals to mg. Okay. By considering these both equations, so you have equation number 1 and 2 in order to find two things, which is number 1 is to find tension and also acceleration. That means two unknowns. So you need to establish two equation. You need to at least establish two equations that involve tension and acceleration. This one is equation number 1 and this one is number 2. So you do some simultaneous equation to find A at certain equation. So this one is given by A equals to m2g. Okay, but just don't memorize the equation. You need to derive the equations, right? So you need to first get the acceleration equals to A equals to 5.17, and then you can replace the acceleration value into one of those values. So here, okay, that T is equivalent to 32.4 newtons. Okay, right. So that's how you do there's problems involving examples involving a pulley system. Okay. Okay, I think this one, okay. Okay. So next, I will present to you the next topic, which is the work. Okay. Hold on. Okay. Okay. So this the next topic should be the topic from chapter 5, which is energy, right? Energy. Okay. But this slides, yeah, I did not put the slide in the link yet because it's still under construction. Okay. So hopefully by tomorrow, okay, we can have the slides. So you can check the slides by 10 p.m. tomorrow. Okay. So let me go to the topic of work, right? So that from this topic, okay, we need to see the work done, okay, by a constant force. So the topic, the definitions of work, okay, is actually we have done the topic, okay, in your school days. That when you apply a topic of work equivalent to force times S, F dot S, ataupun F times with S. But S stands for displacement. Okay, that means force and is a dot product. It's a dot product of force and displacement, where the force is a vector quantity and displacement is also a vector quantity. Okay, when vector quantity, as I mentioned, multiply to each other, okay, we may have a certain value. Okay, when vectors multiply with another vectors, so it's either we can have a dot product or a cross product. So for work, it's a dot product. Okay, F dot D. That means force dot displacement. Okay, or you can call that times force times displacement. But you need to emphasize on which kind of force that should be multiplied to displacement. Okay, so as we obtain here, okay, when there is a fan that pull or push a box at a certain applied force, into a certain displacement from point A to point B. Okay, when you see that kind of situation, the force that this man obtained here, okay, is actually setting from the force is in the horizontal position as, and as will have the same uh, horizontal position as the displacement, because the displacement in x-axis, the force also obtained in x-axis. So you can say that F dot D. So force times displacement, you get force. Okay, but not just that. When you are in Asasi, you should know that there is a possibility of the incoming angle. Okay, that means maybe the force can come into a certain angle. Force come into certain angle, then you need to apply a components. Okay, so you may see next. Okay, but for the dot product, obviously work is a scalar quantity. Okay, as I mentioned to you. Okay, although work it comes from force and displacement, that means both are the vector quantity, but when the multiplications of the vector quantity and of course dot product is getting, so you can see there is a possibility to have, or the outcome of the work is should be scalar quantity. That means where two vectors multiply, it's either to get the vector or a scalar. Okay, but for work, because we obtain a dot product, so the work is scalar quantity. Therefore, we don't need to put a direction towards work. Okay, so like this one, several activities, so typical values of work. Okay, so as stated in the examples, okay, this one is taken from another book. We can see there's a different compared to what you have learned. in the survey textbook, but no, don't worry, it's still the same things. Okay, an intern pushes a 72 kilogram on a 15 kilogram gurney, producing an acceleration of 0.6 meter per second squared. Okay, and how much work does the intern do by pushing the patient and gurney through a distance of 2.5 meters? Okay, so that means there is a mass. Okay, 72 is a mass, and 15 kilogram is a gurney. Okay, that means the patient that has been put, okay, on the stretcher, that means the gurney, okay, producing an acceleration. Both of them, okay, combining 72 kilogram and the 15 kilogram gurney. Okay, so when you multiply with the acceleration, then it can give some force. Remember, okay, the word force comes from the other chapter, the chapter before this, because we have studied about force. So right now, how to manipulate the force when the force times with the displacement. So as you can see, the force and the displacement are in the same direction, or should I say, in the direction that parallel to each other. That means force and displacement are parallel. Okay, force in the positive x-axis and displacement is also in the positive x-axis. So you can see, so we can easily multiply the force towards the displacement by using 52 Newton. Okay, how do we get the 52 Newton? Based on force. That means 72 times plus with 15. So you may get 87 kilogram. That is a total mass of both the patient and the gurney, and the acceleration of 0.6 meter per second square, and you may get 52 newtons, and that is the total force. Okay, you need to find the total force and times with the correct displacement. So the displacement here is 2.5 meters. So you may obtain the work that is also in joule as 130 joule. Remember, the word joule is a SI unit for work, because work is the SI unit for work is joule. Same thing as we do force. Okay, because force is a mass times with the acceleration, kgms negative 2. But for work, it's a force times displacement. So you may get joule. Okay, same thing as energy, because work and energy are related. So in order to find, if the question, okay, assume how far must the intern push the gurney to the 150 joules of work, so you can manipulate the equation to find the distance. Okay, so the question, the distance should be 2.7 meters. Okay, so in here I want to emphasize on the force itself. Okay, before this, okay, the question only involve when F times S. Okay, dalam sekolah F times S, F times S. Okay, banyak cerita pasal F times F kali dengan S, right? But to be on the sebenarnya, okay, the force not only happen to be in the always happen in the along ataupun parallel to the displacement, because we need to know that the work is not just a force times displacement, but in fact you should understand that the force is should be the component of force. Okay, component of force that parallel to the displacement. That is the real word for work. Okay, work is the component of force that parallel to the displacement. Okay, so as you can see, this man is pulling, okay, his luggage, okay, towards some displacement. So the displacement in the x-axis, okay, but he is actually pulling his bag or his luggage with a certain angle, That means we can obtain F cos theta here, okay, F cos theta, and when you see a vector with some angle, so you can bring into its component of F cos theta and F sin theta. But F sin theta is going to the y-axis. That means if we use F sin theta and we multiply with D, it doesn't follow the rules for force, because it doesn't follow the rules for work, because the work should be component of force that parallel to the displacement. So that's why when you look at the figure, when you look at the equation, work is F cos theta times D. F cos theta is the a component of force that parallel to the displacement. Why? Because the displacement in x-axis, and therefore the component of force here is F cos theta. F sin theta did not follow that rules. Okay, so that's why we can say that, okay, in the bracket F cos theta. And when you rewrite the equation, it becomes F d cos theta. So actually, when you write down W equals to FD, it's actually FD cos theta. But when work is parallel to the displacement, the theta is 0, when cos 0 equals to 1. So that's why W equals to FD cos theta. Okay, FD cos theta, because cos theta is parallel to the, when theta is parallel, when force is parallel to the displacement, the theta is 0. So theta 0 equals to cos 0 equals to 1. Okay. So you may see these are the positive work done for the quadrant 1. The force should be positive. Okay, where the angle between 90 to the negative 90. Okay. That means for the positive quadrant, it should be on the quadrant number 1 and quadrant number 4. And comparing to the 0 work, it should be perpendicular. When the force, the component of force perpendicular to the displacement, then the work should be 0. And what happened to the work when the force is actually bigger than 90 degrees and less than 270 degrees? So the force should be the negative. So when the force is going to the other side of the displacement, okay, that means it can become negative work. Ingat, positive and the negative work due to the concepts of because of due to the components. Okay, I think for today that's all for our discussion, and I think we will continue this one tomorrow, insyaAllah, during your class. Okay. Ada soalan ke nak tanya?
Tak ada, sir.
Yeah. Okay, so I see you in the class tomorrow, insyaAllah.